Okay, I'm going to look at the four operations with fractions today. Just before I start that though, I just need to give you just some basics behind fractions. So if I take a fraction 2/3, okay, there are two different types of numbers there. The bottom number is called the denominator, and what that's doing is it's splitting the whole thing into three equal parts. So I'm using like a little chocolate bar there to split it up. So you can see there I've divided it into three equal parts. And obviously, out of those three equal parts, you're taking two out of the three parts. So if I shade that, that tells me how many of the whole part you need. And that's called the numerator. So if I put there, that's called the numerator. How many lots of the whole parts you want. And this is called the denominator, which tells me how many, the number of splitting points of the whole thing. Okay. Before I go on to talk about the four operations with fractions, add, subtract, times and divide, I need to look at something called a mixed number. So take, for example, 3 2/3. Now, when you multiply or divide fractions, you've got to change the mixed numbers to what we call improper form or top-heavy form. Okay, with adding and subtracting you don't do that, but I tend to do that anyway. So if you take that, for example, there's a little trick here. First of all, you know the fraction's in thirds, so I can put the denominator at the bottom, which is 3/3. But how many thirds have I got there? Okay. Well, if you think about it, if I again draw the chocolate bar again, as I did before, therefore 1 whole 1, there are 3/3. Well, we've got 3 whole 1s, so I'm going to draw 3 chocolate bars like this. And that accounts for the 3 whole 1s here. Plus, I'm going to draw another chocolate bar, but I haven't got quite a whole one there, and what I've got there is 2 out of 3. So what I'm doing is I'm shading that for 1 whole 1, this one for 2 whole 1s, this one for 3 whole 1s, and finally the last part of this bit is 2 out of 3. And if you count how many thirds I've got, multiple of 3 there, you've got 3 multiples of 3, which is 9, plus the extra 2, which gives you 11 thirds. And from that diagrammatic way of doing it, obviously you can't keep drawing diagrams, you need a quick way to be able to carry on the calculations. Little trick is here, if you multiply the whole number by the denominator, 3 times 3, that will tell you that there are 9 thirds in 3 whole 1s, which they are there. 3 multiples of 3 make 9, plus the extra 2 thirds, which is there. And obviously we multiply before we add, linking up something called BIDMAS, we will then get 11 thirds. Okay, so that just gives you some idea of how to change a mixed number into an improper fraction or top-heavy fraction. If I just rub that out, because obviously now I'm just going to perform the four operations. Okay, let's look at adding fractions. So my first example here, I'm going to use 3/4 plus 2/3. Now, common errors which happen here is people add the top numbers 3 and 2, which is 5, and 4 and 3, which is 7, and get 5/7, which is not true. What you've got to do is turn them into what we call equivalent fractions and make sure they are got the same denominator. Okay, so we turn them into equivalent fractions and then turn them into what I call like fractions so we can perform the adding. So if you take the denominators at the bottom here, I'll use a orange pen or red pen. There you can see we need to have a common number. Now there's many numbers, if you count in multiples of 4 and multiples of 3, which they go into. Okay, I could pick, for example, 24, but I'm trying to find, if I can, the lowest common multiple. And the little trick to use there is to start with the bigger number, which is the 4, and count up in multiples of that number until the other number, which is the 3, goes into it. So starting with the first multiple of 4, 3 doesn't go into it. So the second multiple of 4 is 8, 3 doesn't go into it. Third multiple of 4 is 12, 3 goes into it 4 times, and that is the common number I'm going to use. So I need to change both those fractions to so they have the same denominator, which is 12 at the bottom. So I can already write 12 at the bottom straight away. Put the add in between there. Okay. Now, what do I have to do to make how many multiples of 4 get you to 12? Times it by 3. Okay. We obviously made the 12 at the bottom because 3 fours are 12, 3 threes are 9. So 9 twelfths is equivalent to 3 quarters. If I was to go backwards and divide that by 3, it will then cancel it down back to its simplistic form, which is 3 quarters. Same with the other one, 2 thirds into twelfths. How many multiples of 3 take you to 12? Well, 4 of them. 4 threes are 12 times the top and bottom by 4, so it's an equivalent fraction. That means it's balanced out. And that obviously makes 2 fours, which is 8 at the top. Now you can add them together. Okay. Another common mistake people make here is to double the numbers at the bottom. Okay, if I was to use a diagram, which I'm not going to do here, the number at the bottom stays the same. So we're dealing with twelfths, but how many a lot? We've got 9 out of 12 plus another 8 out of 12, which gives you 17 twelfths, and there is your answer. Now, the first thing I look at is, can it be simplified? Well, is there a number other than 1 which goes into 17 and 12? There actually isn't. The only number that goes into both is 1, which means I've got it in its simplistic form. It's already been cancelled down already. Okay, 17 is a prime number, so that's a good indication to go for, because a prime number can only divide by 1 in itself. So the only available factors for 17 are 1 and 17. And obviously 1 isn't going to change it, and 17 obviously doesn't go into 12 because it's too small, so it is in its simplest form. They could ask you in the exam to change that from a top-heavy fraction, it's called top-heavy or improper fraction, because the number at the top is bigger or equal to the number at the bottom of the denominator. Now, obviously, we're counting twelfths, so if I was to count in multiples of 12 there, how many 12s can I get into 17? Well, only 1, because 2 multiples of 12 is too much, that's 24. So 1 times 12 is 12. 1 times 12 is 12. What do you have to add on from 12 to 17? The remainder is 5. So you'd have 1 whole chocolate bar with 12 twelfths in it, plus an extra 5 twelfths, which would give me that as a mixed number. Using what I did at the start of this video, you can do that rule I gave you to change from a mixed number to a top-heavy fraction. 1 times 12 is 12, because in 1 whole 1 there are 12 twelfths. You've got a chocolate bar split into 12 equal parts. Add on the 5, gives you 17, so that works from there. Okay, exactly the same thing. If you can add, you can subtract as well. The method is the same, so I'll just take that away. Okay. Okay, I've now got another question here, which is number 2. I'm going to subtract, so it's 4 fifths minus 1 tenth. Again, when you add or subtract fractions, you need to match the numbers at the bottom. Make them into equivalent fractions, but make sure they're like fractions, like meaning they've got the same denominator at the bottom. Same principle again. There are many, many numbers which 10 and 5 go into. I could go 200, but you want to get there in the quickest possible way. So you're looking for the lowest common multiple. Again, this is bringing other maths into the other math skills you will have to use, so it's revising other areas. So I think this is a good idea as well. So again, the idea to get the lowest common is to start with a bigger number and count up in multiples of 10. How far do you need to go? Well, the first multiple of 10 is 10. Well, we can stop because 5 goes into 10, so we've already got the lowest common multiple, which is 10. Okay, so that means I do not need to alter the second fraction because it's already got a 10 at the bottom. So how many multiples of 5 take you, on the first fraction, take you to 10, times it by 2, times top and bottom by 2, so it's balanced out. And that gives you, obviously, we've got a 10 at the bottom on both of these. Well, obviously, that one stays as it is because it's already got the 10 at there. 2 times 5 is 10, and we knew that was going to happen because I set it up to do that. 2 times 4 is 8. Okay, that's correct. If I was to simplify that and divide back by 2, 2's into 8 go 4, 2's into 10 go 5, back to equivalent fraction or your simplistic fraction. Now we can, this time the number at the bottom stays the same. 8 take 1 is 7 tenths. Again, with this example I've chosen here, it doesn't need simplifying because the only number that goes into 7 and 10 is 1. Again, 7's a prime number as well, so the only available factors for 7 are 1 and 7. And obviously that is not a multiple of 7, so it stays as it is, and it's not a top-heavy fraction because the number at the top, the numerator, is smaller than the denominator. So that's finished as it is. Okay, let's move on to now the third operation with fractions, which is multiplying. Now there is a common, just rub that out there. Okay, I'll use my example here. Hopefully I'm going to get one which cancels in a minute. 3 quarters times 2 thirds. So 3 quarters times 2/3. Now the common misconception, I'll demonstrate this here, is people think they have to match the denominator at the bottom. No. You could do it that way, you just make life a lot harder for yourself and you create really big numbers which you're going to have to cancel down. All you do is what you see. Okay, you multiply the top two numbers, which is the numerators, which gives you 3 2s, which is 6, 4 times 3, which is 12, and you get 6 12s. Now that actually can be cancelled down. If you're very good at your times table, you should be able to see that 6 and 12 are both in the 6 times table. In other words, multiples of 6, so I can divide by 6, 6 into 6 go once, 6 into 12 go 2, and then it's a half. You could have spotted that because it's one of those common fractions. If you double 6, which is 12, obviously it's half of it, so you could spot that very quickly. If you didn't do it that way, you could find another number lower than 6 that go into it. For example, you could divide it by 2, half it in other words, because they're both even. 2's into 6 or half of 6 is 3, 2's into 12 or half of 12 is 6, and then obviously they're multiples of 3, which gives you 3's into 3 go once, 3's into 6 go 2, and I've got the answer again. Notice when I'm dividing by 2 and 3, 2 3's make 6, that's like just splitting the 6 up into 2 3's and doing it twice to get to the simplistic form. And that's how you do multiplying fractions. Now, what a lot of people might do, and this is a no-go, you mustn't do this. Okay? Use the trick we did before. Lowest common multiple, well, I've already demonstrated, I think, from the first example, because I'm actually using the same question again on number 1, because I did 3/4, add 2/3. If you went for the lowest common multiple, which is not the way to do it, you times that by 3 to get it a 12 at the bottom, you times that by 4 to get that there. That will then give you 9 twelfths, that will then give you 8 twelfths, and all you're doing is you're creating, the answer is still a half, but you're just making it hard for yourself. 9 8s are 72, 12 12s are 144, and then you've got to cancel it down. Well, again, by that little trick over there, because it's a nice answer, if you double 72, you get 144, so it is a half. I could go through the process of dividing by 2, halving it all, which is 36. That's going to give you 72. Say divide by 4, which is going to give you 9. Okay, that's obviously going to give you 18, and then divide by 9. There's loads of different numbers going into these, and you get the half again. Again, it's a no-go area, yeah? You don't want to be doing that. You want to be just multiplying, as I did at the start here, multiplying the numerators and multiplying the denominators. Okay, let's move on to dividing fractions, which is actually similar to multiplying fractions. Okay, number 4. Okay, number 4. 3/4 divided by 2/3. Okay. Right, going into the explanation of this, when obviously in the class I would go over with diagrams or use diagrams to explain it. So just get straight to the point here. What happens with this? You have to use something called KFC. Okay, so way of remembering it, a familiar 3 letters there. And K stands for keep the same, so that means keep the first fraction the same. F stands for flip, which means turn that fraction round. It's actually given the fancy name reciprocal. That's another word for turning a fraction round. Okay, and the C means change it. Well, the opposite of divide is times. Now, obviously, remember it's KFC for obvious reasons, but obviously the letters in the order go KCF. So all you do, 3/4 stays as it is, change that from divide to times, flip that around so it's 3/2, and then use the process, which I use in example 3, when you multiply fractions. Don't match the numbers at the bottom, you only do that when you add or subtract. You just multiply the 2 numbers at the top, called the numerators, 3 3s are 9, 4 2s, the multiplying denominator is 8, and you get 9 8s. Okay? Nothing goes into 9 and 8 other than 1, so it is as it is. If you wanted to turn that into a mixed number, because the number at the top, the numerator, is bigger than the number at the bottom. So how many multiples of 8 go into that? Well, multiples of 8, 8, 16. Well, 1 multiple of 8 is going to give you 8. 2 multiples of 8 is too big for it. It's gone over 9. So 1 multiple of 8 goes in. So 1 times 8 is 8. 8 to 9 leaves you a remainder 1, 1 and 1/8. Okay? And obviously that works using the trick I used earlier. 1 times 8 in one whole, say, chocolate bar. 1 times 8 is 8 8s, plus the extra 1 is your 9 8s. So they may ask you to write that as a mixed number in the exam, may not. Okay? And that basically, covers all the 4 operations. What I'd like to just go a little bit further, just put the pen on there. okay, is what happens if one of your answers or both your fractions are given in mixed number form. Okay, so I'll demonstrate an example. I'll pick one of the four operations. Let's go 2 1/4 plus 1 3/5. Okay? Well, one of the things you must do, yeah, I always say to students, when you multiply and divide fractions, you must change the mixed numbers to top-heavy form anyway. That's a must. You don't have to with adding and subtracting, but if you keep to the same consistency there, I would say change them to top-heavy straight away. So here that's in quarters, that's in fifths. 2 times 4 in 2 whole chocolate bars. 2 times 4 because it's 4 quarters in every one. 2 4s is 8, so there's 8 quarters in 2 whole chocolate bars, plus the extra 1 is 9 quarters. We're adding. 1 times 5 is in 1 chocolate bar, there are 5 fifths, plus the extra 3 is 8 fifths. Okay, now we're adding the fractions here, so we must make sure the numbers at the bottom are the same. So we need what? Well, the easiest way to do it, as I've said already, is to find the lowest common multiple. So we start with the bigger number, which is 5, and we count up in multiples of 5 until the other number, the smaller of the two denominators, goes into it. Well, first multiple of 5 is 5, 4 doesn't go into it. The second multiple of 5 is 10, 4 doesn't go into it. Third multiple of 5 is 15, 4 doesn't go into it. Fourth multiple of 5 is 20, 4 goes into it. Got you. Multiple, lowest common multiple is 20. So I can now write those two as out of 20 straight away. We're adding them together. Okay. And now what I need to do here is, what do I need to multiply 4 by to make 20? Well, times it by 5. 5 4s are 20 times top and bottom by 5, so it's balanced. 5 4s are 20, we've already got that. 9 5s, or 5 9s, how you want to say it, it's 45. Okay. This one, how many multiples of 5 take you to 20? Times that by 4, times the top by 4. 5 4s are 20, it's obviously set up to do that. 8 4s are 32. Okay. So we've got from there. We now add them together. Remember, the number at the bottom stays as it is. 45 and 32. Well, if you struggle to do that in your head, then do a little sum at the side. It takes you seconds to do it. 5 and 2 is 7. 4 and 3 is also 7. So you've got 77 over 20. Okay? Now, because the numbers are now getting bigger here, we're not sure, is there a number other than 1 which goes into that? I don't think it is. I don't think it works there. I think the only number which goes into this is 1. Because I know 77 is a classic 11 times table, double digit, 7 11s are 77. However, a little trick for you, if you bring it as, because the number at the top is bigger than the number at the bottom, if you now write it as a mixed number, how many multiples of 20 go into it? And that will help with the cancelling down if you've not seen it. Well, what? 20, 40, 60, 80, that's too much. So 1, 2, 3, 3 multiples of 20 are 60. Okay, that means there are 20 20ths in one whole one. 3 20s means there are 60 to 1 20ths in 3 whole ones. 3 times 20 is 60. How much do you add on from 60 to 77? 17, remainder 17. Notice that's not made the 20, so that's why it's not made the next whole one. And you get 20ths. And now it was actually in its simplest form, because if you look at 17, 20, the only number that goes into it is 1. So actually that was in its simplest form, and I've changed it to a mixed number. And then lastly, I'd like to just leave on this. You don't have to use this next bit I use. This is more for more extension work, depending on your ability as well. I'm trying to keep it as simple as possible. But there are, sometimes shortcuts to take. So if I, for example, take the fraction 15 twelfths, let's go with multiplying the number, I'm making the numbers bigger on purpose here, and 32 over 35. Okay, we know from my earlier talk, if you multiply fractions, you multiply the top numbers, the numerators, and the bottom numbers, the denominator. Now, I don't want to be multiplying 15 times 32. That's a rather long multiplication. So is there a quick way of doing it? Well, yes, there is. What you do is you're multiplying the two together, but I don't want to do that because that's too time consuming and I've not finished the exam. So what you then do is, can you find a number which goes into one number at the top and one number at the bottom? Well, perfect pair there, 15 and 35 both end in 5, can be divided by 5. So I can bring the numbers down. There's divide by 5. Okay, so I cross that off here. That leaves me how many 5s go into 15? 3. How many 5s into 35? 7. Okay, is there any way I can do? Okay, it's better than it was. Well, 12 and 32, if you've got it in your tables, multiples of 4. Okay, so I could then divide by 4. So I'm still doing the same to top and bottom. so I'm not affecting the fraction, it's still in the equivalent form. How many 4s go into 32? 8. How many 4s go into 12? 3. So let's just rewrite what I've got down, because I've certainly brought the numbers down. I'm left at the top now with 3 times 8. Still the same question, and 3 times 7. I could probably take it on from there, but why I've got that on the board here, I might as well go and divide by 3. Because I can see there's a 3 at the top and bottom. So if you divide by 3 once, and 3 is going to 3 there once. You've now left with 1 times 8 and 1 times 7, which gives you 8 sevenths. How many 7s go into that? 1 remainder, 1, 1 and 1 seventh. Check it, 1 times 7 is 7, add the 1 is 8 sevenths. And that gives you, that gives you your complete breakdown of all the 4 operations with fractions. And I hope that's been useful, and you can take that forward and refresh your work on your fractions. Thank you very much.